Hello students, today we'll continue the motion topic. Here in this topic we will cover distance and displacement. Okay, so distance and displacement. Now this distance, always whenever we are telling something that 4 meter distance I have covered, 5 meter distance I have covered. So in this topic we are just saying the magnitude, right? That means this information is not fully satisfied by any other person, because your movement is towards north, towards south, you have not mentioned in this statement. So distance, that means you are covering some length, right? But displacement, whenever you are talking like this, yes, I am moving towards north, 4 meter towards north, then I am moving 3 meter towards south, then this is the displacement, right? So this distance and displacement we will study today very well. Here, first we see the definition. Distance is the total movement of an object without any regard of direction, right? I should not mention any direction here, right? So distance means you can move from this point to any other point, towards this direction, or this direction, or this direction. So I am not saying that you have to move through particularly this direction. Yes, 4 meter distance you have covered, or 2 meter distance you have covered, whatever. That means your movement or movement of an object without any regard to direction. We can define distance as to how much ground an object has covered despite its starting or ending point, right? That means suppose I am just going for morning walk and I have covered, there is some, suppose there is some tree here and there is some tree here, and I am moving from this point to this point. So I have covered 4 meter. So this is distance. I have covered or I have just crossed this tree and I have started my journey from here, or it may be here, or it may be here also. Okay, it may be here also. So that means the distance is that how much length you have covered, right? How much length you have covered. They will not ask you what is your starting point, what is your ending point. But if you are, someone is calling you, where are you? So what you can say? Yes, I am 2 meter far away from this tree. Okay, suppose your friend's house is here, and nearby object, that is the tree. So if your friend, that he will ask you, where are you? Then you can say that, yes, I am just 2 meter away from your house, right? So that means you are defining how much length now you have to cover, right? So this is the distance. Now here, whatever I have told you, suppose this is your house, very good looking house, and here you have some tree, and here you have a big tree, and this is this cute person. It may be one of your friend. So he has started the journey from A point, might be he has gone to B point, then C point, then again come back to A point, right? So this is the journey. So here, how much distance he will cover? First, he will cover 4 meter, then he will cover 3 meter, then he will cover 5 meter. That means total distance, how much he has covered, that is the 4 meter plus 3 meter plus 5 meter, that is 12 meter. I am giving another example. Suppose we have one park, and this is semicircle. semicircle path is there, and one person, he or she is moving or walking through this path, and this path is, let it be, semicircular path. Semicircular path. Okay. So, and it has been given the radius of this is the radius. The radius is 2 meters. Okay. So, if he or she is just going for morning walk and following this path, then how much distance he or she has covered? So, this is semicircular path. So, we can say that for the semicircular path, pi r, this is the distance. Okay. This much distance will be covered by the person. So, pi, you know that is 22/7, and this will be your 2 meter. So, this will be the result, or this will be the distance that he or she has covered, right? Similarly, if I am taking another example, here I am drawing, I have a ground, circular ground, and this is the track. So, here we have the path where you are just moving, okay, or you are just going for morning walk or jogging, whatever. So, how much distance you have covered? At that time, you have to find out if you start from here or anywhere. If you start from here, that will not be a matter. That will not be a matter. So, you can see that at that point, how much distance you will cover, that you have this radius. This radius is, I am writing here, suppose this radius is R2 and this radius is R1, right? So, this path that has twice per R2, this is the outer path. Okay, this much distance is the distance of outer part, and twice pi R1, this is the distance of the inner part. So, you have crossed difference between these two, right? So, this is the path whatever you have followed. So, this is the distance covered. That means distance covered means which path you are following. Which path you are following. It may be your semicircular path, it may be circular path, or it may be 4 meter, then 3 meter, then 5 meter. That means here how much distance or how much length you are covering, that is important. The direction, that is not important, right? So, this is the distance. Now, here the displacement. The displacement is defined as the change in position of an object, but here one thing is very important. It has direction as well as magnitude. It has direction as well as magnitude. That means in the previous slide we have seen that how much length you are covering, that is important, but now, yes, you are moving towards north or towards south, that is also important. So, suppose I am moving in this way, east, and we know that north, south, west, right? Suppose one person started the journey from here and he or she is moving towards this position. So, here now I will tell 4 meter I have crossed towards east. If then I am moving here, then I will tell, suppose there is some length I am mentioning here, 4 meter towards north. this N for north, E for east. Again I am coming back. So it will be towards south. That means the displacement that should be defined in terms of direction and magnitude. It is very, very important. And it is represented as an arrow that points from starting position to the final position. Right? This is very, very important. That starting position to final position, I should have some arrow, right? And here you can see that for the displacement, the previous diagram, if I draw here, that was this type of diagram, right? Here we had some tree. Here also we had some tree. And here we had house, cute house, okay? And the person started the journey from here. So here you can see that was 4 meter, that was 3 meter, and from this point to this point, let it be, I am giving some point A, B, C. So this was 5 meter, right? In the previous diagram. So how much is the displacement? Here, the displacement is the shortest distance. That means from point A to C. Maybe the person is moving from A to B, then C, then whatever the tree, at this tree, he is taking rest, very good. But the displacement is the shortest route. That we will study in the next slide. Here, you can see that the distance here, the path, whatever we are following, this path. Okay, then I am moving here, then I am moving here. It looks like hilly area, right? The road of hill station. Fine. So here, this path I am following. So the distance is that from here, whenever this is from A point, if you are moving from A point to your B point, so from A to B, how much is the length you have covered, right? But the displacement is that from A to B. So this is the initial point, or sometimes it is the starting point. And this is the final point or final position or final position, right? So this is the initial point or initial position also you can write. So initial position is point A and final position is the point B. So I have given one arrow here, and the displacement is the AB. The displacement is the AB, and it is a vector quantity, right? So if an object moves from A position to B position, position B, then the object's position changes. This change in position of an object is known as displacement. But if I follow, there are several paths that I can follow to go from A to B, several paths. I can follow this path also. I can follow this path also, right? Several paths I can follow. But for every path, how much length you will cover, that is the distance. That is not displacement. But here, the shortest distance, how much you have in between the point A and point B, that is the straight line, right? So this point A to B, this vector, this is the displacement. Okay, so this is the displacement. Now that means distance formula, all the distance, how much we have covered, that we are just summing all the data, right? So what we have done in the 4 meter is the first distance, 3 meter last, then Suppose another distance you have covered D3, that is 5 meter. I am just talking about the same figure, whatever we have covered earlier. In the slide, whatever we have shown. There was house here, tree here, and from this tree we have started the journey. From this tree we have started the journey. 4 meter, 3 meter, 5 meter. So 4 plus 3 plus 5. Yes, that was the distance. That means total 12 meter. So that means how much distance you are covering, that is D1 plus D2 plus D3. And displacement here, that is the final position minus the initial position, where x0 is the initial position and xf is the final position. That means what? Whatever your from this point to this point, that was the displacement. From this point to this point, that was the displacement. Right? I am giving one example here also. The same example, the park with the semicircular path and the, suppose, radius of the path, this is the R, the radius of the path is 7 meter, right? Radius of the path is 7 meter. So what is the distance and displacement of this path? First thing, if I follow this route, semicircular path, then the distance will be, pi into R, that is 22 by 7. Pi value is the 22 by 7 into 7 meter. So it will be 22 meter. 7 will be cancelled. So 22 meter. Right? So similarly, if I am asking for displacement, at that time, it will be, displacement means what? This is the initial position and this is the final position. So the difference between the final position and the initial position, this is xf and this is our x0, right? So that means, how much is the distance between xf and x0? That is the 2 into r. So 2 into 7. That means 14 meter, right? 14 meter. Now you can see that distance is 22 meter here and the displacement is 14 meter here. Okay. So very much clear what is distance and displacement. In case of displacement, we have to get the value or that difference between the final distance to the initial position, final position to the initial position, right? Here this is twice. Now if whatever I have talked, suppose the person, he or she reached here in this point, reached here. So how much distance he has covered? 4 plus 3, 7 meter. But how much is the displacement? That is 5 meter. Here the distance, that equals to 7 meter, 4 meter plus 3 meter, and the displacement, that equals to 5 meter. That equals to 5 meter. Okay. So this is the difference between distance and displacement. I think now it's very clear what is the distance and displacement. So the difference between distance and displacement, if we see the complete length of the path between any 2 points, the complete length of the path between 2 points is called distance. And displacement is the direct length between any 2 points. Any 2 points. What we have done, started journey from here and the final position is here. So this is the direct point, right? So that was the displacement. So displacement is the direct length between any two points when measured along the minimum path between them. Along the minimum path between them. Now, distance is a scalar quantity because in case of distance, you are not mentioning any direction. You are just mentioning the length you have covered. So, distance is a scalar quantity as it only depends upon the magnitude, not the direction. And displacement, that is a vector quantity. Displacement, that is a vector quantity. Why? Already I have told you, I have to go towards south, toward north, towards east. That I have to mention, right? So that means it has the magnitude, also the direction. Distance can only have positive values, but displacement can be positive, negative, zero. Positive, negative, zero. Fine. What is the displacement? Displacement, that was xf minus x0. Okay. So this will be positive is xf is greater than x0, right? Xf is greater than x0, then it will be positive. Now, suppose I am starting my journey from here. I am starting my journey from here. I have gone to school. Then I am coming back from school and I am reaching here. So what happened? What is the total displacement? This was the x0 initial position. It is the final position. So what is the difference between final position and initial position? No difference, zero. So that is the displacement, right? In that figure also, whatever we have seen, suppose this was the semicircular path. Now suppose I have started the journey from here and I have moved here, then again coming back to this place. So at that time you can see that displacement is zero, right? So displacement may be positive, may be negative, even zero. If xf that is less than x0, then you can see that yes, the displacement that will be negative. That will be negative. But the distance always positive values. The distance always positive values. It has always positive values. Okay. But the displacement that will be your, that may be your positive, negative, or even zero. Now, uncle question. Welcome. So John travels 250 miles to north. Good. So direction has been given here. But then backtrack to south for 105 miles to pick a friend. Okay. John towards north, that is 250 miles. Then back to south. Okay. That means the same distance, same path he will follow. 105 miles. To pick up the friend, what will be the John's total displacement? What will be the John's total displacement? So what is the initial point? So I am drawing here. John started the journey from here. So this is your xi. And towards north, he has covered 250 miles. Then forgot to bring one friend, pick up one friend. So again 105 miles. This much 105 miles he has gone towards south, right? Towards south. So how much is the actually the displacement? This much is the displacement. So what is this value? that is the 250 meter north minus 105 meter south. Now where he is now, suppose he is here. So where he is now? Towards north condition, right? So here displacement, that is the xf minus xi, where xi, here xi, that is the 105 miles. Okay, this 105 miles, that is the xi. Previously the xi was this one. Now the new xi, that is this one. It has been shifted to this one. Okay, so xi is the 105 mile and xf, that is final position, that is the 250 mile. So this point is the final position. This point is the final position. So it will be, the displacement will be 145 meter north, 145 miles north, 145 miles north. Now a body is moving in a square of side 10 meter. Fine. Calculate the distance and displacement in the following cases. From A to B. Okay. See the figure? Square and having 10 meter of side. A to B. That means this. So distance traveled 10 meter and displacement from A to B 10 meter, because this is the shortest path. Now second option, from A to C, that means this point, A to C. How much is the distance traveled? That previously from A point I have gone to B point, then I have to move to CB. So that means 10 meter plus 10 meter. So 20 meter is the distance traveled from A to C. But the displacement, that will be displacement from A to C, that will be 10 root 2 meter. 10 root 2 meter. Okay. Next is the A, B, C, D, A. That means what is the movement? I have started a journey from here. Then I'm following this path, then I am reaching here. Right? So, how much distance I have covered? AB, BC, CD, DA. 10 meter plus 10 meter plus 10 meter plus 10 meter. So, that will be 40 meter. Displacement, your initial condition was point A. Final condition is also point A. That means your displacement is 0. Your displacement is 0. Next, calculate the distance and displacement of a body moving in a complete circle. Complete circle, not the half circle. Complete circle. So, I have started the journey from here and I'm just moving round, again coming back to this point. So, what happened? The initial point position, this initial position, xi, that equals to your xf. That means what? The distance, how much you have covered, that may be your twice pi r, but the displacement, that is 0. So that will be 0. So displacement will be 0. Can the distance be negative? The distance can have only positive values. It cannot be negative. Is displacement a scalar or vector quantity? Displacement always vector quantity. Can displacement may be 0? Yes. If xi equals to xf, the displacement will be 0. What is meant by distance? Distance refers to the total movement of an object without any regard to direction. What is meant by displacement? Displacement is defined as the change in position of an object in a particular direction. in a particular direction, right? If a body covers a distance of 0, what can be said about its displacement? 0. Obviously, it will be 0. Change in position of an object is known as displacement. Total movement of an object without any regard to direction, that is the distance. Displacement is a vector quantity. The motion of a car towards northeast. Fine. So this is north, this one is east. Northeast means somewhere here towards this position. So northeast direction for 300 miles tells us about what? Northeast. That means what? Here the magnitude has been given. 300 miles. Also the direction given, that is the northeast. Right? That means it is our displacement. Thank you and bye-bye.